Starting. Alright, hi. My name is Jesse Fagan. I am going to try to, this is my first attempt at a screencast video, and I'm going to see how well it goes. I'm going to try by analyzing Hillary Clinton's email. So you can see here I have on the screen, this is from the Kaggle competition or the Kaggle site, and you can download the data here. And it comes in, well, it comes in a number of zip files. And it turns out, I think that this actually was, they talk about it here, but the actual Freedom of Information request, like it came in PDF files. And so someone wrote a script here that actually, it's a Python script, and it actually goes through the PDFs, and then it extracted it to a comma separated values file, and then they put those CSV files, and I guess it's still not perfect, but it's probably good enough for now. They put them into a SQLite database, and you can actually go here to the zip file, and the zip file itself has, let's see if we can go to downloads, here it is right here. It actually has the CSV files, and then it also has a SQLite database. A SQLite database is something I like a lot. I really like SQLite databases. It keeps, so all these different things are all in the same place. You can index the files, they index the tables so that searching and aggregating goes really quickly. And the other thing is dplyr, which I'm going to try and use for this project, has a SQLite extension now, or a SQLite tool, which is really awesome. So what I'm going to do is I created a folder. Let's go straight to it here. My Dropbox, projects, Clinton, and I dropped it in here. And what we're going to do is we're going to, well, this is actually, I'm going to start from scratch. I started before, but I'm going to start from scratch now. So I'm going to say new project, existing directory, and we're going to find Dropbox, projects, Clinton, and say open, and we'll create a new project. So one thing is, I think this video is just going to be exploring what's even in this file, because I don't actually know how it's structured. My goal is actually to look at a social network. So what it'll look like, I think, is, see, one thing I don't know about this data, it could either be Hillary Clinton's personal email box, in which case it's just her emails, and then in which case we have an ego network, which means you have a single person here, Hillary Clinton, and she's connected to all the other people, and then they are connected to each other in various degrees. And that would be an ego network, and then we could actually look at a network by removing Hillary Clinton from that structure and seeing how frequently, like, two different people are mentioned in the same email together. So I sent an email to, a few people at once, and there'll be a connection between them. So that's kind of what I'm going for, and I want to visualize it, and I actually was hoping to create some sort of dashboard for it, so I could share it on the internet, and you could actually explore the different interconnections and social connections of Hillary Clinton's email and look into it, and everyone could kind of explore it at their own pace in some way. So that's kind of the idea, and that's what I'm going to try and explore and see if it's even feasible. So let's see what we can do. So you can see on my screen here, it's my first time doing a screencast, and I really dug into this and figured out how to do it because I like this little video. And then I got this thing right here, and this shows you the different keys. So here's a control, and I use Ubuntu, so there's Unity, so there's sort of like the Windows key, and there's Control, Shift. So for instance, create a new script, we're going to do Control, Shift, N, and that creates a new script. And I always like to put in the title, explore and extract Clinton email data, and put it in a nice header. my name is Jesse Fagan, and the date is September. What is the date? It's up here somewhere, right? September 30th, 2015. And I like a little bit of tail on the bottom of my files. I don't like the way it adds. Alright, so something I always put at the top of my file. This actually removes all the different variables from the environment, so I don't end up with, I like the scripts to be completely encapsulated so that at the start and the end it's all together. And then I do a garbage cleanup of the memory. I don't know how necessary that is, but sometimes when I've worked with large files this actually helped a lot. But now it's just, I do it all the time. You find this at the top of all my scripts. Alright, so libraries. So there's some here that I'm going to use a lot. Library, we're going to use dplyr. And this comes with my gritter, or however it's called, for the piping operator. And we'll get to that. Data table is something I like. It's still really nice, and it has this fread functionality, but we'll get to that. And then library, what's something else? Usually reshape is nice, but we're going to look for RSQLite. I don't know if I need RSQLite for... Let me try without RSQLite for a moment to see if I can actually connect to this database using only dplyr. So I looked this up. So I have two monitors here, but one monitor I'm screencasting and one monitor I'm not. Just to keep things tidy. So dplyr, SQLite, and you can see there's a right here. And this creates a database, and it creates a database. So what we do is I'm going to come here and we're going to say db equals what is it again? Help me out, Jesse. It was just there. Source SQLite. Okay. So it's source SQLite, and then the file is database.sqlite create equals false. Although it's defaulting to that, so I'm not even going to worry about it. Alright, so that creates a database, and you can actually see, you hit down here, and you can see it says, it gives you a list of tables. It says there's a table called aliases, email receivers, emails, and persons. So let's look at this for a second. So here's the emails. This is a big chunky guy. This is the one we like. And there's an ID. I think this is just a sequential ID. Let's look at a head of it. So I can actually query it, I think. You go table, actually db, pipe it into a table command, and then we'll ask for emails. What do I get? Okay, so this is what I get. And I can select certain columns like this. So let's actually leave that there because I want all the columns. I want actually names. That's funny. How do I extract the data? Now with SQLite you would just query it with a SQL string. How do I query it? How do I query using SQL? And there's this copy to. What is this copy to command? Let me see here. Copy to destination. So let's call this emails. Data frame. I don't understand. Okay, so in this case we have db. This copies data to a database. I don't want that. I want to now what I read here about SQLite, okay, so is I think it keeps See, this is something I'm going to speed up in post. See, the way it works is it keeps everything on the disk as much as possible. So right here, it never pulls data back to R unless you explicitly ask for it. So the question I have is, how do you explicitly ask for it? So, alright, so here's a list of the columns. And I actually just want to keep, I want to keep this. Alright, so I'm actually going to create a new file. Let me just call it a text file. And I'm just going to call this like db scrap or something. .text. I don't know, it doesn't really matter. And then this is, and then data extraction, data explore. I don't know what .r. Okay, save. So this pulls a table. This looks at emails, and so we have these emails. We have this stuff here. There's metadata subject. All right, so let's look at the columns here. There's ID, which is just the sequential ID. It's practically, it's just there. I mean, it's just internal to the database. So the database, so that things in other tables can refer to items in the data in the emails table. That's what that ID is for. And then look at the Freedom of Information document number. Do they all have individual? Yeah, I mean they all have sequential FOIA document numbers. Okay, and then sender person ID. Okay, so the person ID, email to, email from. I wonder if there's a bunch of stuff. So I think the idea is that the metadata is about the PDF, and this stuff is what was extracted from the PDF according to this. And then extracted body text, the raw text. So here's the people. Now, I wish there was an ID for the individual emails. I wonder if it has anything to do with the case number. Okay, so what I'm going to need, and it's hard to explain, I need, it's sort of like a two-mode network. So what I need is a list of IDs for the individual emails, along with IDs for the individuals. So you have emails on one column, like this is an email, it's dated, whatever, and then you have who sent it. And that's going to be difficult. Let me see what we got. So here's the database, and we don't need SQLite apparently. And putting in extra comments after your comment header actually adds a header for it, so it's like collapsible. It makes it really nice. So I can collapse this now, so I don't have to look at it anymore. And you can actually explore it on the index here. It's really nice. It's one of the things I really like about. Well, there's a lot of things I like about RStudio, and there's some things I don't like too, but it's mostly because it's still young, but it's getting better. I wish I could make the rest of this screen dark. I like dark themes. Like here's my WebStorm. Everything's dark. Okay, so here we go. So here's emails. and I want to extract data from it, and I think you do it with the select command. It looks like what you would do if you actually want to do a query. Contributing next. Normalize various emails. I don't really care. Requirements. Okay. Here's the raw text. What I want to know is from to, and I want the extracted from and extracted to and the date. Can we get that at least? Can we get the from, the to, and the date? And just look at it and see if we can actually just do a really raw, crude network visualization of that. So okay, so I'm going to select extracted from. Oh, here. Actually, don't put it in quotes. Extracted from, extracted to. Here's extracted CC. That's interesting. And then I actually want extracted date sent. Okay, so what does that give me? Oh, alright, let me just. Strange column names. Alright, look at this. So that's neat. That's neat. Okay, and then I think I can pump this into a data table. Alright, let me try that real quick. Attempt to apply a non-dim table SQL. Attempt to apply a non-function. Okay, hold on. Data frame. How do I get it? Okay, laziness. It delays doing any work until the last possible minute, collecting together everything you want to do, then sending it to the database in one step. See, that's actually very nice. It's even especially nice if it was like in another SQL database. Like, I've actually really enjoyed Postgres lately. So that's really neat. So collect executes the query and returns the results to R. So if I do, okay, so hold on, if I go pipe collect, pipe, yeah, then it spits it out. And then I actually want to put it into a data table because I really like the way data table handles data. And it actually plays really well with dplyr, so there's no complaints. So here's what we got. This is pretty nice. Let's look at this for a moment. Okay, so we have, let's see here, emails. Let's just do that for now. And then, okay, so emails. I have, here are the people that are CC'd. Look at that. Okay, so here's a network. I have, this email was sent from this person, and it was sent to these 3 other people. And that's really great. That's network right there. Now, it's interesting to know that this is from something, and this email didn't go to anyone. I wonder if that's a freedom of information like censor, that they actually censored it down. I'm just curious for a moment how big this file is getting. It's my first time making a webcast, so I want to know how big. Oh, you know what? I didn't give it a name of the file. So it's 113 megs right now. Which actually isn't terribly large. I'm not going to worry about it. Okay. So look at this. Okay, so we can extract from to CC date. So that's neat. Okay. So, but here's the thing. I think they have other things in there. So there's table aliases, right? So then there's this thing here where there's everyone's aliased into these person IDs. So they've already done a lot of this work here for me of identifying duplicated names. Somebody might be mentioned one way and then they come out another way. You can see there's 850 uniques here. and there's a column here, and there's a person ID. So for instance, here's Andrew Shapiro A. So you can see, look, he comes up twice. Now he has this row has two IDs, but look, he gets resolved to the same ID here. This name gets resolved to person ID, and this name gets resolved to this person ID. And so they've done a lot of this work already for us, of resolving some of these names. So let's look at this for a second. So then there's persons, right? And then there's aliases. And there's email receivers. I don't know what this table is. It says here's the email ID of the email, and then person ID. Oh, okay. So hold on a second. So let's see here. So what is email receivers? I still don't fully understand that. You know what? I think this is our network data. I'm just thinking for a moment. So if I look at, okay, if I actually collect, I want ID. Okay, let's put ID in there too. So what I'm thinking is that this ID right here corresponds to this ID. So I think this is already a network. I think email receivers is the network. So if I actually go select email ID, person ID, right, and then collect and make it a data table. And I'm just going to make this a little bit easier to read. If I do this, I think this is our network data already. Let me try something. I'm just going to call this an edge list. So we're going to load another library. It might actually be this easy. We're going to load igraph for network analysis. And I'm going to do graph data frame EL. That's all it took. Let's try a G. Alright, so it says there is a very striking number of nodes. It says there's 7,600 nodes. That's because it's a two-mode network, because every email in this is a node. It's emails connect to people. It's not people to people. It's email to people to person email to chain. So it's two mode. You never have emails connecting directly to emails, and you never have people connecting directly to people. You just have people and emails connecting to each other. So we have to resolve that issue. So how do we do that? Well, let's see here. We have this edge list here, right? And it's well, see this. I can put this into. So this is actually two mode, and we can actually project this. Let me see here. Bipartite graph. See, igraph recently changed just dramatically, and a lot of what they're doing I don't understand anymore. So let me see here. So create a bipartite graph. So let me see here. Is bipartite G. So it says false, but that's because I'm going to guess before it requires some sort of type attribute. Checks whether the graph is bipartite, and it just checks whether the graph has a vertex attribute. Yeah, called type. Alright, so there's another issue. I'm going to get into this for a second. So I can't have it. It won't actually come out as bipartite because if we look at the edge list, there's probably, I'm going to guarantee it, there's going to be people here. There's emails with an ID of 1, and then there's going to be people with an ID of 1, so they're not distinct. So I have to do something about that. So what I'm going to do is I'm going to do EL, and I'm going to mutate. Let's just mutate it. mutate. Let's add a new line here. We're going to say email ID equals, okay, I'm going to paste 0. I'm just going to add something to it so that it's distinct, that it's, and its ID, the number doesn't matter. So I'm going to call it E, because it's an email. And we're going to put email ID, and just pump it on there. And then we're going to do person ID equals paste 0. And paste 0 just, otherwise you have to add this separator equals empty, otherwise it adds spaces, and I don't really need spaces. So we're going to add a P, and we're going to say person ID, bump, bump, bump. Alright, let's see what happens. EL. That's great. Alright, so graph data frame, bonk. Alright, so, and then we need to say make bar bipartite. This is a brand new function that I've never seen before. I don't know what it'll do. Error in list. Okay, object cannot be course type logical. Alright, that's ridiculous. Alright, types. So there is a bipartite mapping function. So let's see, mapping. And I don't know, I see, look, okay, here it is now. This is the new one. All the new functions have these underscores. So, okay, let's see here. And then it just goes bipartite, mapping, G. And it comes out true, false, which is exactly what we want. So false, my guess, considering how many of them there are going to be the emails. And then true right here, which is only a few hundred, it seems, are people. Let's just see. I'm guessing that I need to process the data more, and that this email receivers table isn't good enough for a network, because I would actually expect a whole lot more people, because it looks like there's only about 300 or so. Hold on. Let's look at the structure of this. It claims there's 8,094, but I can actually do you can see I'm just, what I'm trying to guess is that bipartite mapping returns a type vector, a Boolean vector, and I'm just trying to like see if I can extract it or whatever, because you should be able to do this. Yeah, see? But then you can't pipe that further. Like if I try to pipe that into sum, which will tell me true, if you add up a logical vector, the trues will be 1 and the falses will be 0, and so you get a number of true. I can do, oh, see, look there, it did it. So there's 418 people. But okay, so what we're gonna do is we need to add something, make. So this is a new thing. I want to try this. I don't think it's really necessary to do this, but I could just add. So make, it says make bipartite graph types edges directed. See, I don't need to do that. Alright, so what I really just need to do is I need to add a type. So we need to add a new attribute to the vertices and call it type, and it's really just this. Type. Okay. And then there we go. Now we have a bipartite graph. And now we want to do bipartite projection. and I'm not entirely sure, so types equals true. Yeah, I want the trues. I think the true is people because it's a smaller set. My dog is stretching out. She's just chilling. And I'm getting really hungry. It's like 1:30, but I'm gonna see if this works, and then I'm going to make myself some lunch. Alright, types. Alright, it says, what does it tell me? It says call type, set bar by type, by invalid by project type, vector size, invalid value. Alright, types, actually don't need that. That's if it's not already part of the graph. See, now what it's going to do, it's going to spit out a monster. Just a monster. Let's see what my computer's doing. It's just chugging away. I'm currently using 9 gigs of memory, but actually WebStorm takes up a huge amount. I just don't want to close it because it has projects running, and I don't like having to start up all this stuff. Oh, this is just running and running and running, and I don't want it to run any longer, so I'm gonna hit stop. Alright, see, one way to do it is using matrix algebra, and I don't know if that's actually what it's doing in the back end. But let's try this real quick. So by part type projection, it's going to ask which is what it really wants, and I want it to pick GP, so graph persons. That's what I'm going to call it. Look, it did it instantly that time. GP. All right, it's 418 people and 620 edges. That's very sparse. So if I plot, okay, hold on a second. Let me see some things. Degree of GP. Look, see, there's a ton of people that have 0 degree. They're not connected to anyone else. What happens if I plot GP? Let's see. And it is a hot mess. Alright, so what we're going to do, is we're going to remove some things. We're going to take this graph and do an induced subgraph, which okay, so hold on, I'm going to create okay, so there's degree of GP, and I'm going to say create an index, which dag GP is equal to 0. And I might actually even reduce it even further, because there's a whole lot of 1s. So if I actually look hist degree GP, look at this. This is crazy. In fact, let's just do a table. If I look at a table here, there's one person in this network with a degree of 147, which is redonkulous. That means they're talking to not quite half, but like a third of all the other people. Alright, and then there's 54 people with 0, but then a huge amount just have 1 number. So actually, let's just look at the core here. I guess I can do a k-core. I haven't done k-cores in igraph before, but let's just get rid of the pendants, which are the 1s. These are the isolates. Isolates have 0 connections, and the pendants, those are dangling pendants. You know, they only have, there's the screen. They only have 1 edge, so they're dangling, they're like pendants. So we want to say which, actually we want to select which nodes have a degree of greater than 1. So we want these guys, these 62 and up. So we just want to look at the network. So right now, this one, this is just a complete mess. Let's just look at see what the core looks like. So, and then we say induced GP equals induced subgraph. The graph is GP. The VIDs equals IX. I don't know what some of those other options are right now. Alright, so then I just reduced it. And this is what it looks like now, and it's really hard to read. So let's try igraph. There's like a plotting options thing now, which I really like. But once again, igraph has changed quite a bit. Options. Let me see here. Here, see, there's something here called igraph underscore options, and this is what we want. I always do my graphing now this way in case I want to do lots of charts, lots of plots. Igraph options. So I want vertex.labels equals false, or is it NA? I think it's NA. No, it might even be null. Okay, hold on. Igraph plotting. Label. It's label. Here's right here. Label. They will be converted to a character. Specify NA to emit vertex labels. Vertex.label equals NA. So remove the labels, because I don't know what the numbers are. They don't really help anything by them being there. And the nodes are, look at these things. They're fatty. Let's get them down. Vertex.size equals 2. Okay. So now we're getting a much cleaner picture of what's going on here. I think there's like one thing I don't like is the margins. Look at this. Look at all this empty space. It's like 50% the size of what it could be. I want to see something real quick. So r par margin. So these are like graphics parameters. So here's the margins, right? So this is the margins on your plots. So I'm actually going to set the margins to 0. 0, 0, 0, 0. I think that'll do it. Yeah, much nicer. So let's zoom in here. So there you go. This is the first. This is sort of a raw email network that I've extracted from the Clinton email database, and let's look at it real quick. What are some things we can see here? We have a big central guy. I don't know who he is. We can figure it out later. And they're connected to just so many people. But you also have two other very central people. And we could see that from the distribution. Wherever. Where did I do? I did this table thing at some point, didn't I? Yeah, it's right here. So you have one person with 147 edges, and you have another person with 83, another person with 62, and then it kind of dies off. And actually, if you plot a table, it looks pretty nice. Plot table deg GP. Yeah, I actually like to do that sometimes. And it actually might be worth doing the log of it. Eh, not really. So, and this is what it looks like. So I've cut this off. So let's look at it again. Deg GP greater than 1, right? Here we go. But I've created new pendants anyway, but it doesn't matter. So here we have, this is what it looks like. It's kind of a log normal distribution, but here's our big guy. He is way up here. He is more than anyone else. And then you have three kind of bigger guys. then you have some middling players, and you have the rabble. Although the real rabble I've removed from the network. And then let's go back and look at it again. So here it is. Zoom. Alright, there's some other interesting things here. It is interesting to note that there's sort of a cluster over here. Like these big people here, they are not talking to the people over here. And this guy has, even though he's big, he's not talking to some parts of the network. And there's a cluster here. You can see this group right here. So you have him and these three others. They're sort of a clique. And then what's interesting, I see another one here. Here's a little clique. And here's a clique. And there's probably a clique here, a group here. So we have some groups. That's always interesting to see. Usually it corresponds to different tasks or projects or topics or things that they're working on. Let's see what else we can do. So I actually really like the eigenvector so leading eigenvector centrality community, whatever. But there's like this is all gonna be. So there's this, and I feel like I can add this. I want to just plot community. Okay, igraph plot community. It's a thing. It's really not hard. I always forget how to do it though. Plot. No, I don't want any of this. Plotting community is. So let me click images. It's going to look like this. This is what it looks like. I think you just plop it right in. Let me just try this. Here, GP communities. Oh, I didn't call it. I've already restricted it, right? Alright, so let me try this again. gp.coms. Oh, it looks like I have to go, it's community structure first. Yikes and potatoes. Okay. No, that did really ridiculous things. Really dramatically ridiculous things. Yeah, that's weird. Why did it do that? Okay, so ignore the convex hulls for a moment because they're overlapping very strangely. I don't know why there's this big guy here. Let me try something else. Let me do a walk trap community. And it's still pretty weird. First off, it should be a weighted network anyway. GP, does it have a weight? Yeah. So GP weight eGP weight. So there's weights. So this actually indicates the number of times that people have sent emails to each other. So something else we could do is actually, instead of removing people who have only one tie, don't worry about them. Only remove the isolates. In fact, I think I'm going to do that. So we're looking at community structure here. Let's ignore it. It's coming out weird right now. It's a weighted network. So, and a lot of these algorithms don't work really well with weighted networks. Walktrap works really well with all sorts of networks. With directed, weighted networks, it's great. It's not as to say it. There's a lot of randomness involved in a walk trap network. Alright, so here's our raw projected person-to-person network. Okay, so then we have the degree, but let's not filter on degree. Let's filter on edges. Let's keep this actually. I want to keep this. But instead, let's filter the edges first. So we're going to do subgraph. I want to see if there's a new one. Is there? No. New subgraph edges. So here's our graph, and we want to do which E of GP weight. So we want to say which weights are. These are the ones we want to keep, by the way. So look at all these ones. That's like one-off communications. I want to know like sort of the important structures in the network. So we're going to find where is the weight greater than 1, and that's all we want. And so here's what it looks like here. And I haven't actually taken out. In this case, I haven't actually taken out anyone here based on the number of ties they have, instead of only taking out edges that don't have. I want the weight greater than 1. I've only taken it so that if you had to have had an email with somebody more than once, I could even weight this even stronger. I could do a like 5, which is actually going to be even stronger. So this is like, these are people who are emailing each other. Each one of the edges here indicates 5 or more emails went between them. So if I actually look at E of GP weights, look, see all these emails, the number of ties here, the number of times they communicated is very high. Alright, looking good. So finally, let's see here, let's just take it down to 1. Alright, so let's reproject it, make it down to 1, and actually I'm not going to filter it all based on degree. And let's look at the leading eigenvector community. Alright, and it gets this again. You have a group here. The groups, they're not actually very useful, are they? It's just not being very useful. It doesn't really matter. So there's a lot of analysis to be done here. This is just scratching the top of it. There's a lot of things to be done. The email receivers table, I'm not entirely certain that it's the table we want to be using. See, it's who received the email, but it doesn't talk. Now that I'm thinking about it, it doesn't talk anything about who sent the email. It might not be. So this table right here, I need to build it for my own network purposes. But this gives you a sense of sort of like how we would do this. And it's just the start. There's a lot of very interesting things here, I think. Alright. Well, I don't know who the heck would watch this, but thanks for watching if you did, if you actually made it to the end. I'm going to sign off here. So thanks, and good luck.